Startups collect a lot of personal information and they need to analyze this both for testing their products, for testing the customer behavior, so that they can improvise on their products. Whether the product is IT or not does not really matter. There is a risk, and that's privacy risk for the data that they have collected. Welcome to my YouTube channel where you regularly see new content on data privacy. We are going to talk today about differential privacy as to how that helps with respect to taking care of the privacy of the information that startups collect. So, what happens? The problem is very simple. A lot of user data being collected, analyzed, reports created, AI models being tested, and if you use them as raw data, the personal information gets exposed. You carry that risk, right? Anonymization can be reverse engineered, so it has to be very, very safe and foolproof to say that anonymization is risk free. There is a risk. So you need to use this data without actually exposing the data. That's the big trick. So, what is differential privacy? Differential privacy is a way by which you add noise to this data. In a way, you are adding more characters within the data such that the data cannot be read or interpreted easily or not at all, actually, depending on the extent that you are doing it. Data cannot be reverse engineered and no one can detect to which individual a particular data set or a data point belongs to. Your presence is not detected. The results stay useful, but the individuals remain safe. An analogy could be you all go in a room and say, how many of the people here earn more than 1 lakh rupees a month? People keep whispering around, you get a random noise, and with that random noise, you get a final statistically accurate answer, but you don't know who are those people who get the exact salary of more than 1 lakh rupees a month. Right? So while people spoke, they whispered, the total count came in, but you don't know which are those. Suppose of 20, 15 people earn more than a lakh per month, you are not able to detect who are those 15 people. How this works? Data is queried, analyzed on request. System adds that mathematical noise onto the data and onto the result, and an aggregated data is returned. And when the aggregated data is returned, the individual information remains hidden. Right? Only the aggregated information is made available. You get the insights, but you don't get the identities of the individuals. You cannot know who that particular individual is. That is what is differential privacy. As an example, Apple uses it on the keyboards. They try and see what kind of words are you writing regularly so that they keep adding them as word suggestions in your next attempt. Google Maps, that's how they map the kind of traffic people in an area are facing so they can warn people coming to that area that there's a traffic there. US population in 2020 for electoral reforms, they added noise and detected the real count of the electoral or eligible people. E-commerce websites, they also want to analyze your behavior, so e-commerce websites use this for analytics a lot, and health uses it to share the aggregated research data, right? To share the aggregated research data. So that's about the basics of differential privacy. There's a full playlist on my channel about differential privacy. You can refer to that. We are going to get into a bit more technical detail in our next video tomorrow. So stay tuned. Subscribe to my YouTube channel if you have not already done that, and share your feedback in the comment section. Thank you.